Okay. Now we have Mr. Sam Bowne with Layer 7 DoS attacks and defenses.
All right. All right. Well, thank you. So, we're done talking about that for the moment. Let me go back to here. All right. So, all right. And there we are. Okay. So that's I teach at City College San Francisco. I teach ethical hacking and computer forensics, and used to teach Cisco classes and things like that. All the basic networking stuff and security stuff. So I'm on Twitter. Twitter is awesome. If you're not on Twitter, just join Twitter. Don't mess around. Anyway, Linus Torvalds said the security community is just a circus. He's sort of famous for saying sort of the things that make entertaining sound bites because they sound kind of foolish. But anyway, I don't know if that's true of all fields of security, but in my field it is absolutely true that it is a circus. Denial of service is ridiculous. There are a bunch of cartoon characters out there just making the world absurd, and I find it very amusing, so I like playing with it. So first I'll talk about some of the characters in the current DoS circus, which is ridiculous and a lot of fun. See if I make this thing higher. Oh, I can, all right. Yeah, sorry, just good. And then there's three kinds of DoS I want to talk about. Layer 4 is the old-fashioned DDoS, which is mostly what you see in the world today, where you take thousands of machines and make a botnet and you take down somebody and they have to stop all his packets. But there's a new kind, Layer 7 DoS, been popular over the last couple of years, where you only need to send a few packets, like 1 packet per second, and you take down a server because you carefully choose packets that do a lot of damage to the server. And there's another one that I'm very excited about, the Link Local DoS, which is a router advertisement attack that kills every Windows machines on a network. And that one I thought was so dangerous that when I came across it, I'm not the discoverer exactly. I thought I might be, but I didn't write the tool. I just ran a tool that was sort of obscure. I secretly contacted Microsoft, like you're supposed to do, and said, hey guys, maybe you'd like to patch this. And the friends I had in Microsoft immediately got me to the right people, and they very quickly got back to me and said, oh no, we've known about that for a long time. We're not going to do anything about it. I said, well, okay, fine then. Then I'll tell the world and give it to my students for homework and everything else. So that's what I'm doing. So, and that is the most powerful attack. One attacker brings down a whole network of machines, which seems like a problem to me, but apparently not to Microsoft. Anyway, so this DoS circus. Of course, you got this guy, Assange, with WikiLeaks, publishing a whole lot of secrets that the US government does not want him to publish. And that creates a stir in the world as various people get all excited and decide either to be on his side or against his side. And for some reason, an enormous amount of them decide that the cool way to support their cause is to take down a bunch of websites, like these characters. These anonymous guys originally just posted obscene jokes on 4chan, but now they decided to take down websites to save the world, supporting free speech through denial of service, which makes sense to them, although not really to me. But anyway, so they started Operation Payback, attacked Scientology, and they mostly did this with the low orbit ion cannon, which has got to be the most ridiculous tool in the world. You could just open a browser to the site you hate and press F5, 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 and if enough people did that, that would take it down. The low orbit ion cannon just automates that. It presses F5 for you. That's about all it does. Anyway, but then Aaron Barr decided he would find these guys and announced that he knew who they were, and so they decided to take him down, and this represented a step up in Anonymous's activities. Instead of just taking him down with distributed denial of service with thousands of people using the low orbit ion cannon, they got a group of 3 or 4 people who were actually relatively competent. So instead of using a technique that is ridiculously out of date, they got up to things that are only about 10 years out of date. They used SQL injection and social engineering, which is very powerful. They took, through a SQL injection, as I understand it, they took over the mail server, and then they sent emails pretending to be the owner of the company saying, hey, I forgot my password. Oh, I forgot my username. Hey, please turn off the firewall, open a port, and they just did all that because it was apparently coming from his email account. And after that, they owned everything, so they dumped his whole email logs wildly to the world, which is fantastically irresponsible. And that is the whole point of Anonymous, is to do fantastically irresponsible things and then you laugh, ha ha ha. Anyway, so they leaked out the emails, and the emails, in their mind, justified their actions because this guy was evil beyond belief. He was writing rootkits for the government, for the Chamber of Commerce. He was going to make fake social media profiles and trick people. He just had all these fantastically unethical and probably highly illegal things he was going to do. So everybody fled for the hills trying to pretend that they had nothing to do with this when they were all deeply in the thick of it, like Bank of America and Chamber of Commerce and such. But now we're all saying they had no idea who was doing any of that, even though the emails show that they did know that, but they're maintaining plausible deniability. Anyway, now they've taken another step up. Earlier this week, Monday, they decided to take down the Chamber of Commerce. And instead of just using a low orbit ion cannon, they used some relatively intelligent techniques here. They used a Drupal exploit, and again hacked into it. So Anonymous does seem to be getting smarter in their attacks. I've been commenting about this stuff for about a year. It's important to me, and a lot of people misunderstand me that I'm on one side or the other. These guys are criminals, and they've been getting caught and going to prison, and I just should lay off that. And the thing that really bothers me about them is they trick children into doing this. They publish websites and say, you can download the low orbit ion cannon and help us save the world. And they tell you you won't get caught because when the website goes down, they'll lose all the server logs. And they totally do get caught. And the only reason they aren't all in prison is because the government can't be bothered to prosecute them all, in my opinion. But the logs are certainly there. The tool is completely obvious. It just sends thousands of packets per second right from your IP address. You can't claim it was a virus or any of their other lame, stupid excuses. They're just a core group of grown-ups recruiting teenagers and throwing them to the wolves. It's cynical and cruel and wrong. Anyway, but it's also stupid. And, this is like when I see, this is, I think, common among people involved in law enforcement at any level, which I sort of am, although I'm not a cop, I'm being in network security. You see somebody do something and say, well, you ought to have better ethics to do that. And if you don't have better ethics, you ought to have better skills than to do it so stupidly. And these guys fail both tests. Especially before they started doing this stuff, when it was just a low orbit ion cannon. I say, oh, come on, guys. Is this a joke or what? Anyway, the Jester. This is why a lot of people think I support the Jester, because the Jester is just as illegal and headed for big trouble, but he's smarter. His techniques are technically interesting. He's ahead of me technically. I wish he would lay off the black hat stuff and come help us study denial of service attacks, because he has a good one. And he's smart enough to port it to a cell phone too, which I'm not. I've been trying to port mine to my iPad, and I haven't succeeded yet. Anyway, so this guy's also going to save the world through denial of service, but he's ex-military, and he uses layer 7 denial of service, I believe, although he has never explicitly said what he does, but he only needs one machine. So he does not need to recruit thousands of teenagers to do his work for him. But then he brings down websites, and he's on the right, whereas Anonymous is on the left. So he's bringing down Islamic jihadist websites, WikiLeaks, and anybody that he feels is opposing the military. And he talks about these things on Twitter. His tool automatically posts these tweets when website goes down. And he brought down WikiLeaks for a whole day from one machine. So, and I was convinced that was him. He goes in chat rooms while he does this, and he said, here, prove it, I'll turn it off. WikiLeaks came back up. I'm turning it back on. WikiLeaks went back down again. So I believe it was one person controlling it. Now, some people accuse him of doing this with a botnet, and I cannot prove that is not true, but I know there is no need for a botnet to do this. Not for the last couple of years. Layer 7 denial service attacks have been here, and so I believe it's there. Anyway, here's Netcraft's WikiLeaks out for a day and a half from this one guy. And that's the Jester. And he and Anonymous have been at each other's throats and doing dirty tricks to wipe each other out and such. And he's on Twitter frequently, he has a blog and all that jazz. So he decided to take down Westboro Baptist. Now these people are incredibly offensive in every possible way. And as far as anybody can tell, that's their business model, is to go to funerals and picket and irritate someone until somebody finally punches them in the face, and then they sue and make money. But anyway, so he hates them, so he took them down for 8 weeks. And he claims that's the longest denial of service attack in history, and it may very well be true, but he did that from a single 3G cell phone, taking down 4 websites, which I also believe is probably true, because I know you could do it, because even I could do it, and even any of my students could do it. Now, I do not know exactly how his tool works, but I know the general principles that make such a thing possible, and that's why it seems to me pretty important. So here's the old-fashioned layer 4 DDoS. Many attackers to one target, and pretty much all you do here is consume all the bandwidth. So then these guys refused service to WikiLeaks, Amazon and Visa and a bunch of other people. Anonymous decided to take them down. So they took their low orbit ion cannon, which is just sort of like a bunch of villagers storming a castle by throwing rocks at it and using pitchforks. And this is the thing it runs. It looks sort of like a fun game. And it sends a bunch of packets. And they brought down Visa and MasterCard and a bunch of other sites. They could not bring down Amazon. They tried. But as you know, Amazon is really big and really proud of their fault tolerance and redundant services and everything. And the only thing that's ever brought Amazon down is them making a mistake inside their own company. Remember when they went down about a month ago, people asked me, was that an attack from Anonymous? And I said, no, I don't think there's anybody on the planet that could bring Anonymous down except an insider making a stupid mistake. But anyway, so they also went down for about a day, 1 day and 13 hours. And that was from 3,000 attackers working together. And it's hilarious if you read the logs of the IRC channel. They do this from a normal IRC server. All those low orbit ion cannons connect to the IRC server. It's not running the right kind of software. It's not on the right kind of server. So they're always losing their connections. So the IRC channel is nothing but, this thing dropped off again. Who wrote this garbage? My software crashed again. What's wrong with you? What's wrong with you? What's happening? I don't know what's happening. Who are we attacking anyway? Is what's actually going on in this storm of confused people taking down MasterCard. But somehow it succeeded. And one widely repeated rumor about that is that one person actually joined who had a real botnet, stole in the usual way of 30,000 machines, and that's why it worked. And that has led to a split inside Anonymous, where one of the leaders, Anonymous claims to have no leaders, but now 2 or 3 leaders have emerged, and they've begun trying to take each other down and become the real leader. And one of them wants to get rid of the mob of teenagers and just have 3 or 4 people with botnets taking things down, because that's the way the criminals do it, and that's the way they think they should do it too. Well, that's the way the other criminals do it, the ones that are doing it for money. These guys are also criminals, but they're doing it for lulz, perhaps to save the world, but mostly just to laugh at everybody. Anyway, and that's the kind of attack that Kaspersky knows about. They asked him recently how many computers would it take to bring down South Africa, and he said 200,000. And I immediately rebelled. I say, that's as ridiculous. It would take 1 cell phone. I happen to know that, and I will show you. But if you did it the way Anonymous did it, it'd probably take 200,000 machines. He's probably right there, and that's obviously what he's thinking of here. So layer 7 DoS is where you take down machines when you really want to take them down and you're not messing around. This has been around for several years. You'll find it in Hacking Exposed 5th edition. A company called Hactics in Israel was doing a penetration test, and they wanted to see how well they could bring down a website. And if you want to bring down a website, you could send pings or SYNs or UDP packets. You take a lot of those. What you do is you look at the website and find out something that's expensive for them to serve up, like their search engine, where you put in a short query in one packet and they have to send back 10,000 hits. And then you send a bunch of those and you'll use up all the CPU on the server. The problem is you have to customize that attack for every website. So it's a lot of work and research to bring down one website. But when you do, it doesn't take very much push to kick a website because you hit it where it hurts. But now we have quite a few generic layer 7 DoS attacks where you do not have to customize it to the website, and therefore you can just make an attack tool and use it. So that's the game here. So here's an HTTP GET. Hopefully this is pretty familiar. This is just Wireshark capturing it. So we got an IP packet, and in here we got a TCP packet with an HTTP layer 7 payload, and that's just GET. It's got a few more lines here, like a user agent and a host and connection. And so what you do is you send only part of a GET, and you never finish it. And so the line waits, thinking, well, this packet got fragmented. That was the first half of the GET, and the second half is coming. And Apache has 255 input channels, and each one of them will wait for 400 seconds. So if you just send one incomplete GET per second, the entire input buffer is full, and nobody can get service out of the server. The CPU is not at 100%. The traffic is minimal. You can run it through an anonymization routine like Tor because it doesn't have much bandwidth, and the server stops. So that's the slow LoRa's attack, which Robert Hansen wrote, and I showed it at last DEF CON along with him, and it works just fine. It only works against Apache. It's really a design flaw in Apache. It does not work against IIS because IIS does not handle incomplete requests in this fashion. However, this one will stop IIS. Are you dead yet? Are you dead yet sends incomplete posts, which is you find a form where you're supposed to send some data like a username and password, and you just send one letter, and then a long time before you send another letter. Or maybe you never send the rest, so you're partway through posting something. And it takes a lot more of them. It takes several thousand of those per second, but it will bring an IIS server to stopping serving. Now, none of these bring down the server. They don't cause the server to crash. As soon as you stop the attack, the server begins serving real customers again. They just make the server unavailable. All right, and there's a couple other ones. There's a Keep Alive DoS, which relies upon the fact that A keep alive packet, I didn't know about this till I read about this. Somebody told me about it on Twitter. A keep alive packet can send 100 requests in a single packet. I don't really know why. Someone out there may know more about HTTP than me and explain why, but anyway, if you send a head method, now the head method doesn't ask for the page, it wants only the header, which you normally never even see, but the header just has a few lines of information about the server. But apparently, if you request a head from a server, the server has to do as much work as to hand out the whole page. Yeah?
It is used to improve caching. For example, if you're talking to a proxy, the proxy will issue head request to the origin server.
Yeah.
And then you won't have to passport the entire page if the head request is giving you the information you would like to see.
Oh, okay. So, but apparently the servers, even if you get a head request, even if a proxy wouldn't pass it, apparently the server still has to hand out the whole page.
No, this depends on the case of the page. It is not
Yeah.
necessary to render the entire page.
Yeah.
In many cases, it may only check file stamps.
Okay, well, that would be good. Anyway, so, but this thing also works. They call it keep dead, and I compile it and it ran just fine. Keep dead runs down here. It's sending these things with 100 payloads each, and it'll use up a lot more CPU than you'd think. It used up 8% in my test. And if you have something better than just a blank page, which is what I use, but you use a page with like a search query on it, then you can easily drive a server to 100%. So it's another form of layer 7 DoS. And again, relatively generic. Now the Jester uses this thing he calls Xerxes, and nobody knows where it came from or exactly what it does, but he has posted videos of it in action, and the video kind of shows you what it does. It's got his local host here making the attack. The attack then goes through the Tor anonymization network or something similar, comes out an exit node so that the defender can no longer identify these packets. They can never track him down to imprison him, and they can't make a firewall rule that will block these packets because they're coming in from random real IP addresses, just like real customers. And then it goes to the target, and as soon as the target is detected with the heartbeat to no longer answer a ping, then it tweets one of those tweets you saw, Tango down. So he just put it all on sort of what looks like a flash-looking kind of interface here, and that's the tool he uses. And then after using this thing for about a year, he ported it to a cell phone and used it to take down Westboro Baptist from a 3G cell phone, which is technically very interesting to me. And as I say, I'm attempting to follow in his footsteps and transfer my attacks to cell phones without much luck so far, but hopefully I will learn. Anyway, the last attack here, because I'm going to demonstrate these, this is why I got a room full of machines, but I'm sure it worked. The last one is link local DoS, and this one is all, I came across it because I'm very interested in IP version 6. We're having to switch to IP version 6 because IP version 4 is full, and so the new protocol, IP version 6, is full of all kinds of mistakes that people already knew better than in IP version 4, and they're making the same mistakes again. But there's a few new mistakes to be made. So in IP version 4, you typically hand out addresses with DHCP. So I boot up the client, it says I need an IP, the server says use this IP, and that's the end of the exchange. There's another packet that goes back and forth, but that's the end. And it's not going to ask for another IP address for a long time, like days. So that's the end of that discussion. But in IP version 6, it's a push process instead of a pull process. The router comes up and the router sends out periodic router advertisements that says, everybody better join my network because I'm the router, and you better send me your packets. And every one of those machines makes up their own IP address and joins that network. That's how it works. It's a push process. And therefore, these router advertisement packets are what controls it, and they go to a thing called FF02::1 is the 128-bit IP version 6 address. Now, if you study IP version 6, one of the first things they will say is IP version 6 does not have broadcast. Well, it has this thing. FF02::1 is a multicast address which goes to all nodes. Now, if there is a difference between multicast to all nodes and broadcast, it is some religious difference, as far as I can tell. It is perhaps some metaphysical sense in which they are different. But for all practical purposes, that's broadcast. It goes to every node. So one packet of router advertisement has some header information, and then it has a prefix. So it sends it the first 64 bits of the address and says, here's the network you're joining, make up any kind of junk you want for the last 64 bits, and join my network. That's how IP version 6 works, automatic addressing as it's usually done. DHCP does exist for IP version 6, but it's almost never used. So What you can do is send out a bunch of IP version 6 router advertisements, and then your poor client machines will join all those networks. Because another fun thing about IP version 6 is everybody uses multi-homing. In IP version 4, client machines typically have only one address. But in IP version 6, every machine, every interface is expected to have 2 or 3 or more addresses. One link local starting FE80 and a public one and maybe more public ones, which is actually kind of a problem too, because it makes it kind of difficult for them to figure out which address to use when they send packets out. But anyway, this is just obeying the RFCs and implementing IP version 6. The problem is that Windows is extremely inefficient at doing this. When you join a network with IP version 6, Windows uses a lot of CPU, and I do not know why. I told Microsoft, and they were told before me about a year ago, and they have not issued a bulletin or alert or explanation of this at all. But for some reason, it takes them a lot of work to add an IP address to an interface. I can only guess that after they add the IP address to the interface, they must adjust the firewall profile and determine if they have a group policy setting and whatever else they have to do. There's a bunch of junk that has to happen from joining a network in a Windows operating system. But the result is, if you send 5 packets per second, you use up all the CPU. And these are broadcast packets, so one attacker brings down every machine on the network that's vulnerable. And all Windows machines that speak IP version 6 are vulnerable by default, as far as I can tell and anybody else can tell. So let's say Mark Hauser discovered this and told Microsoft in July. I didn't tell them until almost a year later, and they told me, oh, that's old news, we don't care. Microsoft's opinion is you shouldn't let anybody get on your local network. Now, you can't send this over the internet yet, although I'm working on that. But you have to be local. I think they may very well be able to make this into a remote attack. I'm working on it because there are a bunch of IP version 6 tunnels that configure automatically. And if you send something through a tunnel, the TTL does not decrement. So I'm working on that. I think with Scapy, I should be able to take an auto-configured tunnel and send a packet remotely. But anyway, even if you don't do that, how much do you really trust your local area network? Now that everybody has cell phones and iPads and laptops and everything, do you really believe that your own local network is safe? For example, right here, if I connect to this room, I kill every Windows machine in this room. And I'm going to do it at DEF CON, by the way. It's in the title of my talk, if they approve it, is the audience, I have audience participation as victims. Anyway, because I tried it. See, I told this, I had this in a podcast, and people heard about it, and so some students in Massachusetts tried it at home, and they killed an Xbox and a PlayStation, they said. And so that's interesting, and I hadn't thought of that. It's not just Windows machines that are vulnerable. Random other networking devices are vulnerable. Anybody that has a sloppily written IP version 6 stack will be vulnerable. So there may be a lot of other devices that are vulnerable. And so we'll continue to investigate it. Cisco and Juniper devices were vulnerable. Cisco patched their stuff, and Juniper did not. Juniper says they're going to wait for IETF to do something. Anyway, there are ways to defend yourself against this thing, but rather than go into that too much, let me just show it to you live. Let's see how my demo works here. Now, I've got this all running in virtual machines, but I don't trust virtual machines. They have hosed me enough. I've given many talks that failed because virtual machines refused to connect properly, so I brought along a bunch of real machines, which are kind of fun too. All right, so let's start with the router advertisement attack. That's probably the simplest one. First, let's see what I have for an IP address on this machine here. This is, on that, you don't need to worry about this screen here right away. I'm just that one there. This here is a Windows 7 virtual machine. And theoretically, it is, all right, it's going to my cell phone, by the way, not to the network that you are all using for what I will become obvious reasons. This is the cheap way to make an isolated network. So this machine is 192.168.11 something or other, and it has only 2 IP version 6 addresses. It has one FE80 address, which every interface makes up as soon as it comes up in IP version 6, and it has one I put on myself long ago, 2::2, when I was doing other projects. So I'm going to send some router advertisements here. I'm going to send just a few. I wrote a tool called Slow Flood, and I'm just going to send 1 packet per second. Send about 3 of them. And then if you look here, you'll see it has made 3 or 4 temporary addresses and 3 or 4 permanent addresses, which is perfectly fine. And so that's the result of sending router advertisements to this machine. Now, if you take a look at some other machines, such as, for example, the Macintosh host here, it's also joining this network. And if you take a look at this Ubuntu Linux machine here, this one here, I ran an ipconfig before I started the talk on ifconfig here, so you can see it has no IP version 6 addresses right now, except FE80. But if I run it again, it's now added 3 IP version 6 addresses. All right, that's the result of a slow flood. All right, I'm going to run the fast flood, but I'm not going to do it till later, because when I run the fast flood, it's going to murder most of my machines. So it has to be pretty much at the end of my talk. In fact, if you leave this thing go for more than about 30 seconds, it will kill VMware, and it will kill the Mac OS X underneath VMware, which is pretty irritating. But so I won't want to do that until a little bit later. But let me do one of the other attacks. The slow LoRa's attack is good, clean fun here. If I do this machine, I fconfig, because this is Linux. I'm 192.168.11.234, and I'm running a server on that address. I guess I can show you that here. Let's just bring up Chrome in my Windows 7 and go to that address, 192.168.11.234, and theoretically, we're going to see if VMware hoses. Oh, good. It's there. Okay, this is just a default Apache server. So there's nothing very interesting about that page, but it is running a server, and the server is up. Now, this is the OWASP tool. When I talked about this at DEF CON last year, we had a Linux-based version written by Robert Hansen and RSnake, and since then OWASP has gotten in the act, and they have written this tool to slow headers and slow posts, which is very nice. A nice attack tool to learn about layer 7 DOS and practice getting your defenses working. So something I learned at a Linux users group, which is extremely useful, is about this thing called server status. This will show you what's going on your Apache server, which is pretty nice. So it's showing me right now, I've only got one connection, which is this connection, me viewing the service. And there are a total of 150 connections it can make. So when I start this attack, it's going to send a bunch of incomplete requests up here, and there they are filling this thing up with R's. Those are requests being processed. And when they all fill up to 150, which is right now, nobody's going to be able to see any pages on this server anymore, because this is just like calling a phone bank and putting all the lines on hold. Nobody can get in. It's not using up bandwidth, it's not using up CPU. It's just 1 or 2 packets per second is all you need, and this server is dead. One cool thing is when you stop the attack, it recovers quickly. Now normally only 1 or 2 of them recover, and they recover slowly. I think I adjusted the timing on this server to make it a little bit faster in one of the many projects I've done on these virtual machines. But that's the slow LoRa's attack in all of its glory. So I think the thing I want to do now, let me see what time it is. Yeah, I'm only halfway through, but let's see, do I have any questions about anything out there? Yeah.
So the previous attack, the IPv6
Yeah.
local flood. The first thing that I thought of was that malicious JavaScript applet you could
Yes.
do using set or Metasploit.
Yes.
Now,
But it'd have to be local though.
Huh?
You'd have to be on the local LAN though.
That's fine. You just get the victim to go to a website.
Yes.
The website runs
Yes.
the applet, and then they nuke themselves.
Yes, see, that's what I'm thinking. That I have not done yet,
Or
but
you
if you
have
could
to
make
have
it
to do their
web-based, then all you need is any one person at your company to click on that link or view that website, and they kill every machine on the network.
Yep.
And you'll see they're dead. I know, that's why it scares me, and I don't think Microsoft is correct to ignore this and not patch it. But yeah, go ahead,
It's
yeah.
not any scary than ARP poisoning on the local network. And if you can actually trigger router advertisement going to a website, that means that you have the same level of access you need to do ARP poisoning, and this is going to work on IPv4, and actually has been working for the last 20, 30 years.
Well, yeah, ARP poisoning would certainly work, and ARP poisoning enables you to redirect traffic, but it doesn't cause all the machines to crash. I mean, ARP poisoning interrupts a network connection for as long as you continue
hijack it,
poisoning.
Or hijack it.
Yeah, or hijack or put you in the middle, and that's certainly true, and there are many ways to do that with IP version 6. But the thing about this is every Windows machine in your network dies and has to be restarted cold. That's why that troubles me. Well, you're certainly correct, and there are a whole bunch of, if you have access to the local network, you can redirect traffic a lot of ways. And I don't know any way to stop that. But this is more than just traffic redirection. It really means you have to restart all your servers. And that means your SQL server and everything else. It seems to me like it's worse, but it's different anyway. Any other questions? These are good questions. Well, let me, like I say, the last one I'm going to do at full speed and kill some machines dead, and there's some interesting things to see there. But let me make sure I've shown you the slides before I murder the machine that's displaying them. All right, so anyway, to protect yourself against this, there are a lot of ways. You can just turn off IP version 6 if you're not using it, which almost nobody is. If you use Windows XP and you haven't turned on IP version 6, it's not there, and of course, then this won't affect you at all. Of course, that's not very good because a lot of people do want to use IP version 6 as you're moving forward, and also if you're using Windows 7 or Windows Vista, then IP version 6 gives you fun features. In Windows 7, it gives you direct access and home groups, and you probably would like to use those. So I don't recommend that, of course, but that is one solution. If you don't have IP version 6 running, then this attack won't hurt you any. You can turn off router discovery with a simple command line. That will mean you no longer listen to router advertisements and auto-configure. And that's what I think people should do on their servers. You probably do not want your servers reconfiguring to automatically join networks for the same reason you normally don't let servers use DHCP. You put static addresses on them, and you probably want to put static IP version 6 addresses on them, so you might as well turn off router discovery. But your clients probably do want to use auto-discovery. That's the point. Clients are portable machines people have carried in. So for those, I think you might want to block rogue router advertisements with a firewall. The Windows firewall can do it. You just have to turn it on. This is not a very strong defense, however, because it's using the source IP version 6 address to tell the authorized router advertiser from the unauthorized ones. And an intelligent attacker could sniff the network and find out that address and spoof packets from that address. So it'd be easy to circumvent that, but it's probably good enough to protect client machines, which aren't the end of the world if they go down anyway. And of course, Cisco has their proprietary solution, RA Guard, and presumably Juniper will get on board one of these days, and other people will have RA Guard on the switches, so you can choose one physical port to be the only port that's allowed to add RAs to the network. The problem there is wireless, but you probably just don't want to accept any use over wireless networks anyway. So there is a feature called RA Guard on the newest generation of switches, if you have the best equipment, but small businesses and people with old equipment are not going to have that. And there is actually a way around that, theoretically. The very latest version of the attack tool I'm using here, which is THC IP version 6 from Van Housen, has a fragmentation header just to get around RA Guard. Because RA Guard is what the big enterprises are planning to save themselves with. But the one thing about IP version 6 is instead of having an optional field in the header, which is not always used, they have a cascading series of headers. So your first IP version 6 header has a next header field, which tells it what's going to be in the next header. And you can have as many of these chained as you want. It is part of the specifications. So packets actually have a different number of headers. If you have a more complicated packet, it turns on more headers until it has put all the information it needs in there. So if you turn on a fragmentation header, you may remember that earlier packet. Let me go back to that earlier Wireshark capture there. Here's what a normal RA packet looks like. You've got the header is here, type 134, router advertisement, and then you've got checksum and all that stuff. And then you've got ICMP version 6, which is what router advertisements are, including a prefix. But if you want to get past RA Guard, you just add a bunch of unnecessary fragmentation headers here, telling it fragmentation header, next header, fragmentation header, next header, and down here is the ICMP version 6, so the packet looks different. Now, I do not have access to a switch with RA Guard to test this, but Van Housen released this apparently in the belief that this will circumvent RA Guard, and if it does, RA Guard is pretty lame, because that's just obeying the RFC, and this could happen to a packet if it was too large on the way in, as it would be fragmented and at the source. Anyway, so, but that is another possibility, and that is one of the many headaches of IP version 6. Anyway, to defend yourself against these attacks, the defenses are actually very lame. I mean, right now, the only reason your website is up is because nobody hates you, or all the people that hate you are stupid. That's it. And this is why I thought the gesture was so important. If one guy that hates you is enough to take down your site, This is unacceptable. Nobody can run business and government or anything. No matter what you do, somebody hates you. There's some people out there that hate this talk, believe it or not. And if any one of you hated this talk and they could shoot me dead, that would be an unacceptable way to run a conference. And that's the way it is on the internet. So this is bad. No one person should be able to do anything that would bring down your website. But that's the way we are right now. So if you want to defend yourself, there's mod security, which was being talked about earlier today. Mod security does have some protections against layer 7 DoS. The ones I've seen are not that good. You can stop that particular tool, like you can stop a lot of connections from the same IP address, and that will limit the damage of the slow loris attack when done with that Windows-based testing tool, but it would not stop the jester because he runs it through Tor, and they come in from all different addresses. You can also filter traffic if you can find something similar in it, but it's really not all that effective. Better solutions are a load balancer. Load balancers will actually save you in a lot of ways. Now, a load balancer, especially a hardware one, sits in front of your web server, takes the requests, and then parcels them out to your server cluster. This one takes that one. So it doesn't even pass any request onto the server at all that isn't complete. If you send half of something, it waits for the other half and doesn't bother the server at all. So I tried that. I set up 2 Linux machines and attacked it through a load balancer, and that did make it more resistant. However, a sufficient number of these packets would in fact overwhelm the load balancer. So you just moved the problem from one device to another, but it was stronger in my tests, and presumably a stronger load balancer could protect your server better than the server software itself. It's the same principle as getting a web application firewall to protect your web application by stopping most of the bad stuff. Akamai protects people against denial of service all the time, and I got a chance to talk to the Akamai guy responsible for this at Layer 7 at our conference in San Francisco in an area, and he told me some very interesting stuff. Now, when Akamai gets a denial of service attack, they work from local caches of your page, so they don't need to get to your server, and they have effectively many servers to answer quickly, so it's harder to bring them down. You can also use DNS redirection to move the attack to another place. If the attacker has been friendly enough to attack you by IP address, you can reroute your domain name to go to a different server, of course. That's an old trick. And then the attack will keep attacking the old one, but your real customers will go to the new one. But the fun he told me I'd never thought of was this. When you go to a website, if you go there from clicking onto a link, it passes in the referrer header, this strange misspelled field in the HTTP request that tells it where you came from to make it easier for people to determine what search engines are giving them the most value for their advertising or something. So what you do is you put a little page in front that is invisible to the user that contains nothing but JavaScript, and all the JavaScript does is reload this page again. And then when the page, if I go to samsclass.info and I came from Google, I'll see the JavaScript. When I come in the second time, I will be going to samsclass.info from samsclass.info. The referrer will equal the target, which is something that could never happen under normal circumstances. And you only show the real page to people where the referrer equals the target. This is brilliant because you have to use very small resources to handle each request. You just handle one little short page, just a little JavaScript, and the attackers will never get to the real page because the only people that get to the page are people who actually take the response, render it in a browser, and execute the scripts. Real customers trying to see your website. These clowns running attack tools that are sending partial requests and not really caring about the answer are not going to do that, so they will never get anything but your little JavaScript page, which is cheap for you to put out. And anyway, that struck me as a very brilliant solution, and that kind of thing would really stop this whole category of attacks in a broad way. That's the kind of good thinking, a whole new way to go at it that will stop the whole category of attacks rather than just trying to write specific rules to pick out each one of the attacks. Anyway, so I thought that was pretty good. Although I'm not aware of an open source product that will do that for you off the shelf, but it doesn't seem like it would be too hard to roll your own. I haven't done it yet, though. Yeah.
Robo, R-O-B-O-O. It is
Robo.
a plugin for Nginx. Does exactly that. Actually, it does more stuff. It also injects Silverlight and other challenges to the browser.
Robo. R-O-B-B-O?
R-O-B-O-O. Yeah, it's also.
Let me bring it right up here because that's awesome. This is an Nginx plugin that does that.
Alex Baker was here at Black Hat, actually this year.
R-O-B-O-O, right?
You can also do that with have your, like, say, Apache virtual host set up to do
Ah.
HD access, that you can just dump
Yeah.
rerun rules into the HD access to do exactly that. It's like all people coming in that are hitting this type of page, the refer has to be this.
Okay, good. This is the Layer 7 defense. Let me save it right now. It'll be here in my links for my students and for me.
The point is the attacks don't render anything.
Good.
The way around that, though, is fudging the user, or not the user, fudging the refer. You can do it like dumping it.
All right, and you can also do it with HD access. Well, good, good. I got to play with that, and I appreciate the tips. Anyway, all right, let me see if I got anything else here, and then I'm going to kill my machines, just like a concert where you burn those instruments at the end. Well, there's also a counterattack. HD Moore did this. This is kind of fun. People are attacking you, so you just redefine your DNS to point back to their control server. Then they blow themselves away. Of course, your website is down while this happens, and it seems to me like you could argue that it's illegal. Here you are creating a DOS against somebody, but they're probably not going to go to the cops, and I don't know if they'd win anyway. It's kind of funny. Like if I had a shield that bounced the bullets back at the guy shooting me, I don't know if that would be legal or not. Anyway, but it brings them down, that's for sure. All right, and I put a bunch of references here. Yeah, my talk is on my website already at samsclass.info. Let me just point that out. If anybody wants any of this stuff, I got a bunch of links to it all there. And if you want any of my stuff, it's all available for anybody at samsclass.info. And there's the PowerPoint for this talk is right there. So now, let me kill these machines. I have 20 minutes left, so I should be able to kill them. All right, now I'm hoping to preserve the attacker, but I didn't want to do it until the... All right, so let's get this sucker back. Quit this, go here, Control-C, look at my IP addresses. Okay, I got a few of these right now. But for this, we're going to let the attack run a little longer. And I need to have Task Manager. There, we can see the CPU percentage. That's the fun thing to watch on this one. All right, and the attack is here. Okay, / flood router 6 ETH0. Now, I bring this one up again. Let's try top here. Come on, sudo top. All right. So there's Ubuntu Linux under the same conditions. And up here you should see the CPU. Right now I have 0.8% of CPU used, really nothing much at all. All right, and here's my Windows 7 machine using 0% of its CPU, so let's run this attack. Now each one of these dots is 100 router advertisements, and there you go. And looks like it's not going to do anything to me, so I'm going to switch to my backup machine. It's either killed it so much it won't respond at all. Oh, that's what happened. Huh, that's kind of fun. It killed it so bad it can't even show me Task Manager anymore. And notice that the Ubuntu machine is still at 0.5%, and I don't think it ever got that high. Let's take a look at what happened to the Linux machine. Oh, there. Now this thing finally responded. It's at 100%, and it will be at 100% for a good long time. A company that was testing the devices with RAGuard said that this machine had a backlog of 4 hours at 100%, and they were using a rack-mounted server with 8 cores. So that Windows machine is toast. My Ubuntu machine is doing fine here, and if I hit Control-C and look at the IP addresses, you will see why. Ubuntu is not as stupid as Windows. Now, why does Windows try to join 100 networks a second? I'm not really connecting 100 routers per second to my network. How stupid can it be anyway? Ubuntu does not fall for this. It just adds the first 10 or so and then ignores all the rest, like anybody with any sense would do. That's why it doesn't suffer. Now, here's another Windows machine over here, and I thought this one is kind of fun, another way. Let's see if I can get it to project. Searching for source. Oh, good. So here's another poor little Windows machine here, and you can see its CPU is up at 100%, and if I try to see, yeah, I can't even get this pane to come to the front, I think. Let's see. Yeah, it's not even taking keystrokes or anything. There it goes. I can do ipconfig. Pipe more, very slowly, and I might possibly be able to see some of the IP addresses that this poor abused machine has gotten. Let's see if it will do anything at all. Okay, I was able to print the first line. We may see some going by here. Anyway, what I wanted to show you here which is kind of fun, the CPU is at 100%. Now, if I'm able to disable the adapter in network connections, it will stop the attack. I can no longer do it because the machine doesn't respond well enough. But this machine is using a USB attached NIC. So I can do that. Okay, the attack has stopped. The network interface is gone. There's no place to put any of those IP addresses. And yet, it sits here at 100%, and it will be at 100% for a good long time. What is it doing? I would like somebody at Microsoft to explain to me what is happening right now. Why is my machine using its 100% of its CPU, attaching IP addresses to an interface that is not even there, and doing God knows what, group policy and firewall settings, running around like a hamster chasing its tail, when there's obviously no benefit to doing this. Anyway, I think that's it. That's all I wanted to show you. By the way, it actually got back so you can see some of them. So, all right, good. And I guess I have a couple of minutes if anybody has any questions. If not, I guess that's it. I got some cards up here if anybody wants them. All my stuff is available on my website. Thank you. Okay. I don't see any questions. All right.
Okay.
Let's try and clean up my mess here. This thing actually responded. Maybe I can shake it down normally. Hey there.